Here. All right. So yes, welcome everybody to a first look at Crop C, Simplified Carbon Monitoring on Croplands, presented by us at Point Blue Conservation Science. Again, my name is Lishka Arata. I'm Point Blue Communications Manager. I use she, her pronouns, and I'm happy to be your host today. I'm zooming in from the unceded lands of the Coast Miwok people, also known as Petaluma, California. And I'm really excited to hear more about how you plan to use Crop C in your toolbox and hear the things that you're curious to know about how this works for you. Again, please share where you're joining in from today in the chat and one thing you're curious about learning today. If you are new to Point Blue Conservation Science, or if you just like a reminder, we are a conservation nonprofit that works to conserve birds, other wildlife, and ecosystems through science partnerships and outreach. We're headquartered in Petaluma, California, but we work throughout the state from the Sierra to the sea and beyond, from Alaska to Chile and as far as Antarctica, studying Adelie penguins. Our penguin crew is down there right now studying Adelie penguins in the Ross Sea. Our focus has been to address the twin threats of climate change and biodiversity loss by increasing the pace, scale, and impact of climate-smart conservation. And as we approach our 60th anniversary next year, we're leaning into the concept of connected conservation to further increase and sustain conservation action impact locally and globally. In order to do this, we obviously need to dig into what's happening below ground with all of you. So today, our soils team will describe our vision for the Crop C program at large, including forthcoming project design, data submission, and results interpretation web tools that complement the flexible suite of protocols. So whether you're a farmer, technical assistance provider, a carbon researcher, or just soil carbon curious, we hope this webinar provides value to you and supports the shared impact that we can all make together. So let's get to our presenter introductions. I'm excited to introduce Avalon Cook, conservation monitoring ecologist with Point Blue Conservation Science. Avalon's work focuses on scaling up monitoring for carbon stewardship practices and on working lands nationwide. She believes strongly that the conservation science is most impactful in partnership with the expertise of landowners and stewards, and that scaling our impact on the landscapes we rely on is fundamentally a collaborative act. So Avalon earned a BS in Conservation and Resource Studies from UC Berkeley, where they worked on projects ranging from amphibian disease genetics to rangeland management and spatial data analysis. Now based in West Sonoma County, they contribute to rangeland carbon monitoring with Point Blue while pursuing passions like wildlife photography, mushroom cultivation, and music. So please please join me in welcoming Avalon Cook. You're welcome to put sentiments of welcoming in the chat, use reactions, things like that. So welcome, Avalon.
Thank you, Lishka. I'm super excited. So good
Yay!
to see everyone in here.
Wonderful. And next, I'm excited to introduce Dr. Erica Foster. As Director of Soil Research and Conservation at Point Blue, Erica oversees Point Blue Soils projects, including rangeland carbon monitoring and protocol design for conservation practices. She's passionate about the land and its resources, and she leads a dedicated team while studying the impact of ecosystem services on both above and below ground carbon. Erica earned a BS in Natural Resource Conservation with a minor in Wilderness Studies from the University of Montana, and a PhD in Ecology from Colorado State University, where her research focused on the importance of organic amendments on soil carbon and microbial nutrient cycling. Now based in Sonoma County, she remains dedicated to environmental field education and enjoys outdoor activities like climbing, sailing, and trail running. Please welcome me and I keep mixing those two, sorry. Please join me in welcoming Erica Foster. All right.
Hello, everyone. Thanks so much for joining today. Looking forward.
Wonderful. Thanks, Erica. And last but certainly not least, I'm honored to introduce Greg Richardson, soil carbon specialist at Point Blue. He focuses on soil health, holistic management, and systems thinking with a focus on behavior change and place-based solutions. In November of 2023, Greg joined Point Blue to lead the development of a soil carbon sampling guide for croplands, aligning with his passion for helping farmers and ranchers build resilient, ecologically attuned operations. Previously, he served as Director of Research and Monitoring at Piscinas Ranch, advancing landscape health through agriculture and managing diverse projects like compost production and riparian restoration. He holds an MS in agroecology and soil science from the University of Wisconsin-Madison and a BS in environmental studies and economics from the University of Michigan, Ann Arbor. Everybody, please join me in welcoming Greg Richardson.
Thank you, Lishka. Really good to be here.
Awesome. Welcome, Greg. Okay, so before we dive in and before I pass the mic to Avalon, I'm going to ask everybody to please put your questions in the Q&A function. So you should find the Q&A button in your menu. I think it's on your bottom bar for most of you. We will keep the chat open and we encourage you to comment on what you're hearing, celebrate what you're hearing, add comments, things like that, communicate with each other. But please do add your questions to the Q&A function so that we can track your questions and circle back to them at the Q&A time at the end of the presentation. So thank you very much for following that guideline, and I'll add reminders to the chat if we get off track there. And with that, I shall pass the mic to you, Avalon. Take it away.
Great. Thank you so much, Lishka. Those introductions were awesome. I'll go ahead and share my screen. Okay. Yep, so as you know, we today are going to be talking about the CropC protocol. We're super excited to get the word out about this program. So many collaborators, scientists, farmers, practitioners have invested a lot into sort of helping us vision and build out this framework. And I know some of those folks are on the call today, so it's just, this is really fun. We're going to be talking about the CropC monitoring program, which provides user-friendly guidance for practitioners to track changes in cropland carbon in response to management practices over time. So just a quick overview of our little agenda today. We'll go over a few concepts around management as a carbon stewardship tool in cropping systems. We'll talk a little bit about our framing as we identified the need for more guidance around monitoring, how we sort of started thinking about monitoring motivations and worked from there. We'll talk about what the CropC framework is exactly, what we think makes it special, how we think it meets the needs of land stewards and the community at large, and then we'll walk through a hypothetical monitoring project to sort of make it all concrete, how we can use the CropC framework to assess change in response to a cover cropping project in a vineyard. So I am going to, with that, pass it off to Erica.
Wonderful. Thanks, Avalon. So I want to bring us out a little ways and talk first about why we're interested in monitoring carbon. There's obviously been a lot of conversation and excitement around carbon, specifically for climate mitigation. And our team wants to expand that definition and think not only about carbon for climate mitigation, but also multiple benefits that carbon provides. And so we're really using carbon as this primary indicator of cropland health. And we're interested in monitoring carbon because it makes up living organisms and organic molecules, and in a way tracks both energy flows and really the biologic cycle within croplands. And so you can see here on the right, we have this diagram of carbon co-benefits, both carbon in above ground biomass and also carbon in below ground biomass and soils. And so aspects above ground include habitat for wildlife, so birds, and maybe livestock that are integrated in cropland systems. We can think about carbon climate change mitigation and carbon storage in woody biomass, for example, and also the air quality benefits, for example, that those living plants create for us. And then below ground, we think about how carbon makes up organic matter in soils and relates to soil fertility and how plants have access to nutrients, and specifically focused on soil structure and aggregation, which helps with water infiltration and water storage, and then as well as the carbon storage for climate change mitigation, as it's locked through photosynthesis pulled out of the atmosphere and potentially stored for tens, hundreds, or even thousands of years in soils. And today, again, we really want to think about how a cropland system that has carbon, especially in soils, can be an extremely resilient system. And so it can help producers both adapt to climate change situations, perhaps from boosting fertility through soil structure and water storage, for example, and also that aspect of climate change mitigation as well. So through protecting and rebuilding carbon, we're creating extremely resilient systems. And so that's the lens and why we're using carbon as a primary indicator. And we know that through cropland management, we're able to build and protect carbon throughout systems. So practices that are often incentivized through various programs across the US will put on different plantings or carbon amendments, or perhaps any kind of management intervention that can alter carbon content both below ground and potentially above ground as well. And so although these practices are often incentivized, there could be little to no guidance as to how to monitor those practices and to really evaluate how successful they are on your property. And so there are many, many different ways that people think about carbon, and many different management objectives really that can use carbon as a primary indicator. And so this list here is just showing a couple of different monitoring and carbon measurement objectives or motivations. And this can go from objectives that are less rigorous, such as asking questions about land ethics, such as, is my conservation practice increasing or decreasing carbon simply? Or perhaps consumer storytelling about whether or not the conservation practices are improving soil health through a carbon lens, for example. And all the way up to situations and monitoring motivations that require more rigor in terms of monitoring. So that could be for demonstration network projects, or perhaps even asking scientific questions or evaluating projects for competitive grants. And so our framework with CropC is very flexible to fit all of these monitoring motivations. We'll also say that you could use CropC potentially to take baselines for carbon markets, but we want to differentiate that these carbon protocols do not meet the typical measurement, monitoring, reporting, and verification aspects to enter into carbon markets. So we want to leave that on there because you can take baseline measurements, but that's not exactly what this is designed for. And I want to take a second just to pass it off to Greg to talk more about the development of the protocol itself.
All right, perfect. Thank you, Erica. I really appreciate that. And yeah, so I'm going to be starting to get into the nuts and bolts of what CropC is. And so we talk about this larger CropC monitoring program, and there are really two key pieces of it, which are free resources for you all to tap into. And so the first is, as shown in the photo here, a handbook. It's a printable handbook, which serves as a guide for setting up sampling plans to monitor carbon, in particular around tracking changes that result from specific types of management practices that are sort of thought to or known to accumulate carbon over time. And so this handbook and its development was funded through the USDA through their Program for Climate Smart Commodities grant. And we are a part of one of those that is led by the Wolf's Neck Center. And so this actually just came out a couple of months ago. So this is pretty new. The second piece of the CropC monitoring program is a secure database. And so we are creating a centralized location for the data to be stored in a secure way in order to advance understanding of how these practices are impacting carbon levels, both at a local, field, or property scale, but then also kind of aggregating that information together so that we can learn collectively about what's occurring in a region and what seems to be effective. So the next thing I want to do is actually just pause because I feel like it's worth just acknowledging that there are other resources that are out there for supporting monitoring on croplands. And so CropC was really designed to be complementary to those, but also to build on top of some of what exists by creating some unique features that we want to share with you. And so I'm going to kind of walk through a couple of things that we feel like makes CropC distinct. And the first one of those is that it was a very collaborative process in putting this together. It wasn't just our team sitting down and deciding what we think is best, but we really brought in a lot of experts from 32 different entities that are either science-based technical advisors that walked through some of the key considerations together of what makes a good sampling plan. And then brought this to another sort of set of advisors that are farmers and ranchers, technical assistance providers, other folks in the farming community to make sure that what we were offering was relatively accessible and practical to implement. The next thing is that the way that we have set up our recommendations really maps onto each management practice that is sort of commonly implemented for conservation purposes. And so we have a list of the 9 key management practices here on the right-hand side. And what I want to note is there are a couple of things. One is that living ground cover on the left is sort of a consortium of like filter strips and buffer strips, like perennial ground cover, things along those lines. But we sort of set this up in a way that each management practice is going to have a specific number of samples that we recommend collecting, and Avalon will walk us through that in her case study. And also a certain sort of time duration between your first sampling and your next sampling. And so because each practice has a different expected impact and sort of time duration until you would be able to like detect that impact in your monitoring, we felt like it was important to reflect that in our recommendations. Next slide. So we've referred to this a little bit already, but there are a range of different motivations for why somebody might want to monitor carbon. And there are associated different sort of levels of rigor that might be warranted, depending on whether you're trying to publish an academic paper or you are trying to kind of, for your own management, understand general directions of change over time. And so we've highlighted in the monitoring handbook the different key decision points for where you could choose what we're calling a higher tier or a more rigorous approach versus a lower tier, just to help folks who are using CropC to kind of make decisions that make the most sense for them and for their context. The result of this is that we then we wanted to have an inference scoring system to reflect sort of the data quality that comes out of those decisions. And so depending on whether somebody samples the top 12 inches of soil or goes down maybe 2 feet or 3 feet, whether they are only sampling soil organic carbon, or maybe they're also sampling soil inorganic carbon or above ground biomass, these kinds of decisions would kind of feed into this inference scoring system, inferring or kind of how basically the idea of the inference is it's how much can we infer from the data or how much confidence can we put in our interpretation of the results. And so we've scored this from 40 to 100, and that provides transparency both for the person who's creating the sampling plan, but then also on the back end regarding the level of rigor that supports the research that was done. And then finally, this is the last slide that I'm going to share with you. I mentioned the database previously. By having a database that this information is stored in, we really feel like it multiplies the value of doing the monitoring in the first place. And there are a couple of reasons. And so I'm going to actually kind of walk us just quickly through this flow chart. If you look at the bottom left, you can imagine yourself or another user is submitting monitoring data. We will have an option for what level of privacy for your data that you are willing or comfortable with. That information then gets sort of stored in the secure database that we are creating. And we will automatically be able to create a report that helps to analyze that data and supports interpretation. So that's of benefit to you all. But rather than the research that you're doing just kind of living kind of by itself and not influencing kind of a larger system, by having it stored in this database over time, as we get more information from various field sites and various practices, we can start to run additional analyses that's sort of aggregated, it's anonymized to understand to what extent, are these practices having the impact that we would expect them to? So we're enabling sort of advanced understanding around this topic by working at it together. So we feel like that's also a really valuable aspect of this work. So with that, I will pass it back to Avalon to walk us through a case study of how this actually looks in practice.
Great. Awesome. Thank you, Greg. So just to kind of make all of these ideas concrete, we're just going to walk through an example of how we might build a monitoring program around a practice going on the ground. So we've made up an example today to sort of guide us through that little case study that we're going to walk through. The best way to do this when we're helping people develop a monitoring plan, we always like to make sure folks have like a pretty clear vision about what they want to learn and how they want to use the data and what their goals are. It helps to sort of return to that throughout the process to kind of anchor us. So in this case, in this example, we're going to say that we're planning a CDFA Healthy Soils project to plant cover crops on a 3-acre vineyard unit on California's Central Coast. You want your monitoring project to support adaptive management decision making and the potential for direct-to-consumer storytelling, regenerative marketing, that kind of thing. But your primary goal is to track changes in soil carbon stocks for soil health and climate resilience over time. I've chosen, as we go forward, to make this example as accessible as possible, which means we aren't shooting for like a super high inference score or data that could necessarily be published in a scientific journal. I want to keep it really simple, inexpensive, and just informative of exactly what we're interested in for today's example. So we'll kind of return to that. The first thing, quite simple, is to determine the boundaries of the area we're going to monitor. The basic guidance in CropC is that the monitoring boundaries should match the extent of the practice you're putting on the ground. Pretty easy. In this case, we're going to say that cover crops are going to be planted throughout the vineyard unit on the left. So that is going to be our main study area. We also encourage folks as much as possible to monitor a business as usual control site along with the site where the practice is being implemented, as that really helps us learn a lot more about practice impact. Although, as I'm sure you can imagine, it's not always available, it's not always practical, and it's also really important that the control site matches the treated site in a few key ways. In this example, we're going to go ahead and check that we generally have the same soil type between the treated and control sites. The topography and size are about the same. So that's part of what makes a good control site. If it's not possible, that's totally fine. Because the other thing we're going to do to make sure our results are interpretable is, oh no, where'd my slide go? Well, it looks like I lost my slide for the baselines, but what that basically means is that we're gonna do our first round of monitoring before the conservation practice goes on the ground, which is just a really good way to make sure that we are able to quantify over time the entire impact of the practice. Which also isn't always possible. We've had folks come to us a few years into a conservation practice and want to get some monitoring done and track continued benefits into the future. But if you can get baseline and a control site, that's going to make your results so much more interpretable and really contribute to that final inference score. So for in this example, we're going to say we'll do our first round of monitoring, say in the spring, and then broadcast our cover crop that fall. Awesome. So the next question is exactly what am I going to measure in my monitoring plan? CropC supports a suite of what we call carbon indicators. These represent the major forms that carbon can take on the landscape. A massive proportion of that is soil organic carbon, but we also support other carbon metrics, including herbaceous biomass, woody biomass, root biomass, For this case, I've decided we'll look at what I sort of consider the basics, which is soil organic carbon and bulk density. You can see these three indicators on the right represent what we call supporting metrics. They obviously aren't measuring carbon itself, but they provide a lot of really valuable context to help us interpret, especially the soil carbon data. Um, so these two together, soil organic carbon and soil bulk density, can help us track changes in soil carbon stocks over time, which tells us how much soil carbon is stored in the study area. And then if you're interested, we have all these methods for measuring plant biomass, but we're not going to worry about that in this example today. Oh, there's my baseline slide. Let's skip past that. Great. So once you've selected your indicators, the next step is that you can use the CropC handbook to select one of usually a couple tiered methods for measuring them. We provide multiple options for measuring each indicator to just build in additional flexibility. Tier 1 methods are the most accurate, they're the most precise, or they provide the most information, but they often come with trade-offs in that they're usually more expensive or more time-consuming. For this example, I won't like get into all the weeds here, but I've just gone ahead and chose the tier 2 method for soil organic carbon and the tier 2 method for soil bulk density. They're both tier 2, but they're still great methods, and they'll go ahead and save us some costs on the back end. Great. So since we've chosen our methods, we can go ahead and fill in what we know to be the per sample cost for analysis for these metrics, which is a number you can get from as a quote from a service lab in your area. Um, and and then there's also some costs associated with tools to invest in. In this case, I've added the cost of a soil sampling auger and some extra measurement tools that we use for our soil bulk density method. And if you're not investing in these tools yourself, then there's none of that one-time cost, but we just wanted to include it in this example. So to finish our little budget sheet here, the last thing we need is to decide how many samples to analyze for each indicator. So the way we provide guidance around sampling densities in CropC is through lookup tables that look like this. Ultimately, there's three factors that determine the number of samples you need. The first is the expected impact of the conservation practice you're putting on the ground, which is represented at the top of this table where it says cover crops. You can imagine a different one of these tables for each practice that Greg showed in that grid of 9. The second factor is the expected carbon variability of the study area. Basically put, if it's a really flat, homogeneous area, we don't need as many samples to characterize the entire site. But if it's got a bunch of different soil types, it's really varied terrain, things like that, you need more samples to capture that. So we'll return to that in a minute, but the last component for determining sampling densities is just up to us. It's a spectrum of how certain we want to be in our results. That's these blue levels on the left. Within our protocol, we broke this up into what we're calling standard, advanced, and academic classes. And this is basically just a way of batching up the what you end up getting as being the statistical certainty of your final results, batching it up in a way that's easy to understand and easy to select from. So today we're going to go with a standard certainty level. Like I said, I want to give folks an example that's relatively simple and accessible. So now to get our final sampling number, we just have to decide how variable our study area is. In our handbook, which is available to use, we have this little checklist activity that can help you assess the variability of your study area. For relatively small, flat fields like this, they tend to come out as low variability. I've sort of trimmed down our checklist table here to make it a little easier to look at. But we overall consider things like size, topography, soil types, drainage. So you can consider the area you're working on, work through this activity, and assign it a variability level. It's not super surprising that these came out as low. They're pretty small. there's not a lot going on in terms of management interventions. So now we have all the information we need to select our number of samples for the soil carbon analysis. I've gone ahead and circled the recommended number for cover crop areas that have low variability when you want that standard certainty level, and that comes out to 6. And then in Crop C, we provide a little extra guidance about how many samples to analyze for other selected metrics. Here, the guidance is to look at bulk density for at least half of the soil carbon samples. So that's what we're going to do. We're going to go with half in order to keep things, like I said, easy and inexpensive. So that'll come out to 3. So now we can fill in our entire budgeting spreadsheet here. Note that I've doubled our number of samples. That is because we're looking at both a treated site and a control site. So those recommended numbers are just for one of those. So I've gone ahead and doubled those. I'm also going to go ahead and do all the math here for you so we can get a total project cost and a time for field work. So for this labor per sample that's going out in the field taking your soil samples, it's pretty quick for each one. I'm going to add 5 minutes to each one to account for just time getting between the sampling points. And this is what we come out to. One thing to note about this figure is that the majority of that cost actually comes from this investment in equipment that I showed you, those one-time costs. So if you're buying that equipment yourself, that's not a cost you're going to carry over into future years of monitoring, or if you're collaborating with someone that has these tools ready to go, I'll just go ahead and do that math for you. Without the investment in equipment, it comes out to about $318 and about, regardless, it's about 4 hours of work out in the field getting your soil samples. One of our major goals in developing this framework is to help people make the most of their monitoring resources. For example, the lookup tables are there to help people make sure they'll actually be able to track change over time, that they're taking enough samples, that the benefits of their conservation practice will be visible in the results. Another way we try to help people maximize their resources is by providing guidance around resampling intervals, like Greg mentioned before. This is to help ensure that when you do conduct resampling, so after your conservation practice has been on the ground for a while, and you have some time to accrue those benefits, re-soil sample and see what changed. It's important that you wait until enough time has passed that the benefits of the practice have had time to accrue to a detectable level. For cover crops, based on the data in the literature and our math around sampling densities, all these things, the recommendation comes out to a 7-year resampling interval. Recommendations that are kind of in that like 5 to 10-year range can be kind of surprising for people, which is understandable. It might not feel like a super meaningful management timeline for a lot of land stewards. Of course, these are just recommendations. We've had folks say, actually, we're going to do this every 2 years just to see what we can learn, which is great. It's just important to keep in mind that monitoring more often than recommended can reduce your likelihood of detecting a change. So you can also take these resampling interval recommendations or your chosen resampling interval and divide that monitoring cost that we just looked at over those years for like a per year investment in monitoring. And for this plan that we're going over, it comes out to about $40 a year. That does not include that monitoring equipment, since that's not a cost that sort of carries over time. Great, so we have designed our whole monitoring plan for the most part, and the handbook includes this appendix where you can sort of plug in and like encode the decisions that you made throughout this process, and it'll then calculate your inference score for you. What we've done here results in an inference score of 66. It takes into account the indicators we chose, the tiered methods we chose, and then some project design elements like our baseline, our control site, a few other details that I didn't dive into today. And then I just want to quickly acknowledge that we also, in addition to this sort of step-by-step decision-making process, We also provide protocols for field work and sample processing if that's, sort of relevant for your project design. We provide recommendations on service labs and requesting analyses. And that is all available to you in our CropC handbook. And we'll get to in a little bit about how you can access that. But that's our example. We've got a few more slides here just to wrap it up, and then we'll move into Q&A. So I will pass it back off to Erica.
So next, we want to share a little bit about our vision for the CropC program. And I also want to quickly mention that this is a parallel protocol with our Range C monitoring program. And so together, you'll see them discussed and communicated about as our agricultural carbon monitoring program. And so that we've been calling the Ag-C framework and program. So within both of these, both CropC and Range C, we're really focused on producing data that's useful for on-farm management. That means that we provide interpretation and analysis of the monitoring data at meaningful scales, including at the field scale. So we want to provide summaries that can inform management directly. We also aim to use the Ag-C monitoring program to build technical assistance provider skill sets. So we want to ensure that folks are learning this scientifically rigorous monitoring approach that can be applied to contexts far beyond the agricultural carbon monitoring program. We also want to evaluate the impacts of practices by region, particularly in underrepresented and underserved areas. And currently we have a lack of data in order to really motivate or distinguish in which areas, climate, soils, et cetera, certain practices are most effective. And finally, we want to use this data to inform policy and incentives, which is only possible through collaboration and users who elect to share their data beyond the Point Blue database as well. And so that means that we could plug data into additional monitoring and analysis efforts that could feed back into wider policy shifts. And we're very excited on the soils team to be working with a really incredible internal ecoinformatics team who's diligently working to develop web-based tools to make the monitoring and data entry for CropC a breeze. And so currently under development, we're working on the database and user experience internally, and that really provides us more control over the exact layout and the manner in which the data input, the data experience and input for users is created. And so currently we have a first version of a tool to design monitoring projects. And so that's what's displayed here on the right, where you can select the indicators you want to measure, as Avalon discussed, and different aspects and protocols that you would use to monitor carbon on your cropland. We're also currently working on the imprint score calculator, so that's automated for users. We have a questionnaire for management history information, as well as the current implemented conservation practice details. We have an automated generation of sampling points based off of polygons that are submitted. And then finally, we're continuing to work on how the data is securely submitted, stored, and then subsequently accessed by the users as well. And so currently we're implementing a secure semi-automated approach, and working with our ecoinformatics team, we'll have a beta launch of the full web-based tool in early 2025, maybe pushing into spring slightly, and then the full launch of this web-based user interface would be in the fall of 2025. So we're very excited to have that unique feature for this Ag-C monitoring program. And then I also want to share a sneak. I think this is really exciting. We have a short video that just shows an interactive map where a producer can go in and touch on specific points. And this is really useful both just from baseline data, but can also show change over time as well, because we're really interested in that conservation practice impact. So this would be an example of a baseline map where you could view carbon or pH or soil texture across the property. So we're going to continue to work on this user dashboard for interpreting results and provide regional comparisons. We hope to incentivize data sharing by giving people access to these reports when they're able to share their data. And then we also want to integrate a project cost calculator as well, so that folks who are coming into their monitoring project with a specific budget can really easily see how many samples they're able to take and measure with specific indicators. And then finally, we also will include training materials and protocols for both the field and lab methods as well. So we're very excited to continue working across those aspects with our informatics team. And then this is our second to last slide here. This, as you know, Greg and Avalon have mentioned, has been this amazing collaborative process to develop both CropC and RangeC. And so we would love to stay engaging with you on updates to the protocol and any feedback you might have. You can find out more information at this website, pointblue.org/ag-c, where you can download the CropC handbook. We'll be posting information about upcoming events, including technical assistance provider trainings across the country. And also there you can find access to the webinar recordings as well. So if you have any questions that we can't get to in the webinar, feel free to email us. Also, we always welcome feedback. As we said, this has been a huge group effort. We know that folks on the webinar today in the audience have participated already and provide really crucial comments to the protocol, and that's how we've settled on this really broad adaptive framework. And if you want to propose a training workshop, again, please reach out. We're looking to expand into locations around the country that really could benefit from additional training, and we'd love to reach out and go into new geographies. So please don't hesitate to shoot us an email or give us a call too. All right, so with that, we can take any questions you might have. Again, we want to make sure that we're able to really create these tools so that they're most useful to producers and provide feedback at the farm scale, as well as creating a really secure aggregated database so we can answer wider questions and improve conservation practice impact. So thanks so much for joining, and we'll open it up.
Yay! Thank you so much. Thank you, Erica, Greg, and Avalon. That was awesome. I hope you all enjoyed that as well. So yeah, come on back with your videos, Avalon and Greg. Nice to see your faces again there. So yeah, please everybody add your, okay, good. Questions are coming into the Q&A. I see a couple there and I'm seeing some added. So please do keep adding your questions into the Q&A function. Our first question comes from Emily. They say this is amazing, and they're wondering what was the motivation for keeping the data private and how much data, number of farms have you do you have so far? Who would like to take that one?
I'll take that. So thanks, Emily. So we're going to have data sharing levels that are going to be presented to producers as they move through the user interface. So currently we have data across a set of rangelands that was from a previous project. And we just launched CropC recently. And so we're still collecting data on farms, but we have over 30 projects coming to us through the USDA Partnerships for Climate for Commodities grant that we're on with the Wolf's-Neck Center. And through that project, we're going to be bringing on 385 distinct projects that cover both rangeland and croplands. And so by the end of, or the beginning of 2028, we'll have 385 projects monitored, as well as additional projects that come through.
Awesome.
And we're happy to answer follow-up questions about data sharing as well.
Yep. All right. Thanks for joining us. Guihua. They need to jump off now. All right. So our next question from Dorothy: are you or anyone else looking not just as at the cost of monitoring, but at the resiliency or financial benefits that would um, accrue to the farm and impacting economic viability. That makes sense. Who wants to jump on that one? Greg or
Right.
Erica? All right.
But yeah, go ahead, Greg.
Okay, yeah, well, we can tag team on this one if you'd like. So my response to that is that, the protocols that we've developed are really to support people who are interested in monitoring carbon, and so we want to make sure that the costs that are associated with that are transparent and clear. And so that's really where the focus of our kind of cost association or cost calculator that we've created, where that comes from. But it is a really good point that by implementing some of these practices, we expect that there are going to be benefits to the farms, and for the sake of those who are ranching, to the ranches, as it relates to improved soil quality, structure, water holding capacity, nutrient cycling. There are a lot of benefits that can come from the carbon being in the landscape, as sort of Erica was talking about at the beginning of the webinar. We are not specifically offering insights on how to monitor the sort of financial benefits of those. But I think that for the particular landowner, I think there's a question of what their priorities are, whether it's, trying to reduce the number of tractor passes that they're making and the diesel inputs, the labor associated with that, or if it's reducing fertilizer inputs, or if it's in a dry land context with irrigation, how many fewer times do you have to turn on the pump? So there are a lot of different ways that that could look. And so I think that it would be a matter of, if someone was interested in that, setting up a study in a particular area where you can kind of prioritize what the key issues are, to look at, as it relates to kind of what would help sort of make the business case to a farmer, or a rancher for implementing some of these practices. I am not specifically aware of individuals who are looking at sort of answering those questions right now. I know there are some academic researchers who have looked at like the financial benefits of cover crops, for example. But not something that sort of comprehensively fits over the scope of what we've created.
Awesome. Do you have anything to add to that, Erica?
I'll just say that our partners at Open Team are also working with USDA on a couple of different aspects of the economic components of conservation practices. And so we're staying up to date on their efforts and also looking to build out and perhaps create layers onto the AgSea database ultimately. And so we do have a social scientist on staff, for example, who's interested in collecting some social information so that we can start to kind of build upon the ecological data and start thinking about kind of these social science questions. And perhaps in the future, we might also have a component that includes economics directly. I like that idea. Very important.
Nice. Great question. All right, our next question comes from Miguel. How long do you recommend maintaining the control plot for comparison?
Hi, I can take that. It's a great question. Control plots are funny because they are extremely informative, but they are a logistical bottleneck when you're not setting up a scientific experiment for the sake of it, but you're layering monitoring onto someone who's just running a farm or trying to do what makes sense for them. The ideal scenario would be to maintain the control site for the life of the monitoring project, which could be, in perpetuity. The main reason for that is that one of the biggest benefits of monitoring a control site is to sort of help tease apart any changes that might be happening on the landscape, that aren't actually due to just the conservation practice itself, but to like long-term climatic changes or other environmental changes. So the longer we have that control site to sort of track changes, alongside the treated site, the better. That said, we have a lot of people, we've talked to plenty of people who are like, well, if we think this thing like works, quote unquote, or is like, good for resilience and good for the landscape, why wouldn't I do it everywhere? And ultimately, yeah, sure, but if what we're really interested in is quantifying and teasing apart like the causality of that change, the maintaining the control site is for as long as possible is the best thing to do. So it's a funny one where, you want stewardship to, take precedence, but if available, maintaining it for as long as possible would be great.
Nice. Thanks, Evelyn. That makes sense. And for those who have asked questions, please feel free to add in any follow-up questions you have to the Q&A as well. Our next question comes from Emily. Where is the funding coming from for continuing the platform?
The age-old question of database maintenance. So currently, as we mentioned, our funding is coming primarily from this partnership with the Wolf's Neck Center through the USDA Partnerships for Climate Smart Commodities Project. I'll say that broadly, Point Blue approaches funding through trying to diversify funding sources as much as possible to ensure that the programs are sustainable. And we have one of our biggest kind of chunks of data and databases, the Avian Knowledge Network, for example. And we've been collecting bird monitoring data since the 60s. And long-term ecological monitoring is one of Point Blue's superpowers, and we are extremely committed to this. So we have, as I mentioned, this informatics team that is funded to make sure that the database is maintained and that it's up to date and interfaces with the connecting software, for example, as our world continues and technology continues to advance. And so we're going to be looking to continue to plug into wider efforts. And I've been really interested in some conversations we've been having with the NRCS and their effort around MMRV, for example. So we've been thinking a lot about how we can have different protocols and efforts within these wider groups and monitoring programs that actually fit under the umbrella of the Ag-C program. We can identify a specific inference score for these protocols and then potentially ingest information and data that's coming in from those efforts. So we can serve as a data repository. And so we're continuing to pursue those types of collaborations. And if anyone on the call is interested in collaborating, you can reach out and we'd be happy to discuss further.
Awesome. Maybe we have time for one last question before we wrap it up here. Anybody have any other questions from the audience? How about a question that hasn't been asked, which might be of interest to the audience here.
Oh, it looks like we had one coming just now.
Okay, good. All right, last question from Sarah. Would it be possible for a user to upload or view soil data for multiple sites and farms? Sarah is part of a farm collective and can see herself using this to monitor soil health on their farms. Who would like to start with that one?
I can take a stab at it really quickly.
Great.
Yeah, it's a good question. There's a couple ways to think about this user interface and this database. One being that, in theory, a farmer or a producer is uploading data for their own site, but we know in a lot of cases, and especially in the case that we're currently piloting our web interface for, is more often than not, it's going to be a practitioner, a technical assistance provider, someone who, say, works with a network of land trust sites or something like that, who is sort of stewarding data along for monitoring within, their local network. And so we're figuring out now basically how to sort of allocate ownership and partial ownership of different projects so that there can be permissions from one party who submits data and then making that available to the associated land stewards. So that is functionality we're looking to build in, if that answers your question. Does that sound right to you, Erica?
Mm-hmm.
Nice.
Yes, and I'll just add really quickly that because we're developing this user interface in-house, that we're able to make changes as well. So we're making sure that we have a framework that kind of works for our use cases currently, we have connected this user interface and the database design and structure into FarmOS as well, which is currently a program that Open Team uses, as well as the USDA in some aspects, such as the PODS program. So we're really excited to have the ability to push and pull data into FarmOS and this wider system. And ultimately, we'll be getting into an approach that really is that the user, the producer inputs data once, and then they're able to use, multiple systems. And so we want to make sure that we're making something that fits those needs. And so thanks for bringing that up, and we'll make sure we're continuing to work on that, as Avalon said.
Can I add one quick thing before in the minute that we have? I also just want to appreciate the question, because I think this is part of our intention in creating this flexible framework, that there's no prescriptive one way that you need to do this. And so that if you have a network of farms or a program, a nonprofit that you're a part of, that you feel like this could be applied towards some of the monitoring that you want to do, you can choose the path that makes the most sense to you. And then apply it to those different locations. And so I feel like what you're asking about is actually one of sort of our intentions for a use case for why we developed this and how we hope that it gets rolled out. So we definitely want to support that. If there are ways that we can help to answer questions and making that possible, feel free to reach out and let us know.
Wonderful. Well, thank you all, Point Blue Soils team. This was educational for me as usual. Hope you all enjoyed it, the webinar. You got some new knowledge. You're excited to connect. We're all in this together, so please do reach out and visit pointblue.org/agc. You will find contact emails to reach out to our team there, and resources that you can download and explore. So yeah, we are all excited to connect and keep this good work going to create healthy soils and ecosystems together into the future. So thanks everybody so much, and have a great rest of your week.
Well said, Lishka.
Thanks all
Bye,
for
everybody.
joining.
Thank you,
Take
everyone.
care.